Good afternoon, all. In my last video, we have discussed about introduction of visible spectroscopy. Now we are entering into the main topic. It is useful for physical purpose also. Types of electronic transition in UV visible spectroscopy. Types of electronic transition. Let's see. According to molecular orbital theory, if any molecule absorbs UV visible radiation, if any molecule absorbs UV visible radiation, its electrons are promoted from binding to non-binding orbital. It is more promoted from or moving from binding to non-binding orbital. According to molecular orbital theory, if any molecule absorbs UV visible radiation, its electrons are promoted from binding to non-binding orbital. In other words, simply I told you that moving from ground state to exit state. Here, orbital theory from binding to non-binding orbital. Let's say actually 4 types of transitions are possible. 4 types of electron transition will occur. 4 types of electron transition. What are those? N2 5-star transition, 5 to 5-star transition, N2 sigma-star transition, sigma to sigma-star transition. Means here N is non-bonded electrons or lone pair of electrons. These electrons are excited to the 5-star. Next 5 electrons. These 5 electrons absorb UV visible radiation will undergo excitation. Are moving to anti-orbital, non-bonding orbital. Then this again last type is non-bonding electrons are moving to the sigma-star. Means moving to exit state, that is sigma star. Then sigma electrons are involved in this time. The sigma electron moving to sigma star transition. Here diagonally I represented here bonding and non-bonding orbital. You can see first this type of transition. This is here I represented this. This is sigma. This is pi. This is non-bonded electrons, and these three are known as bonding electrons or bonding. These electrons are present in bonding electrons. Here this pi star and sigma star that indicates excitation state. Here according to molecular theory it is anti-bonding electrons. You can see here this is the first one. This is non-bonded electrons which are moving to the pi star. Means this bonding of non-bonded electrons, non-bonded electrons are moving to pi star. Means N2 pi star transition. Then second one, 5 electrons are moving to 5-star transition. Then third type, here this one again non-bonding electrons are moving to 5-star transition. This is N2 sigma star transition. This is N2 sigma star. And fourth one is sigma to sigma star transition. These sigma electrons are moving to sigma star. This is exit state. Here it is ground state. In other words, it is bonding electron. This is anti-bonding position. Or non-bonding position. These 4 types of transition occur. According to this sequence, for first one, second one, third one, fourth one. Means this is the energy required for transition. Means N to 5-star transition requires very lowest energy. Then 5 to 5-star transition requires lowest energy as compared to remaining. And this N to sigma star transition requires lowest energy as compared to remaining. And sigma to sigma star it requires a very high energy as compared to remaining. Among the all, this transition requires lowest energy for transition. Let's say indicate first one N2 5-star transition. Here you need to understand that these non-bonded electrons or lone pair of electrons are undergoing excitation. That you need to remember. Here N2 5-star transition is given by unsaturated molecules which contain atoms like oxygen, nitrogen, sulfur and halogen. N2 5-star transition is given by which molecule? Unsaturated molecules which contain atoms like oxygen, nitrogen, sulfur and halogens. Here we know that N means non-bonded electrons. Non-bonded electrons are present in where oxygen or nitrogen or sulfur or halogens which contains non-bonded electrons. Then pi star means 5 bonds must be there. Where 5 bonds? Here unsaturated molecules will consist 5 bonds. So this transition will occur by these kind of compounds. Then this is equality bands, nothing but peaks. Due to this transition is known as R bands. the bands appeared by N2 5-star transition is known as R bands. In GPAT purpose also, R bands are occupied by which kind of visible transition means which kind of electron transition means N2 5-star. Here R indicates radical or free radicals. That is one pair of electrons. Okay. Then it requires lowest energy. I told you that among the 4 transition, this N2 5-star transition requires lowest energy. And absorption occur at higher wavelength. As I told you in introduction topic, okay, here energy is inversely proportional to wavelength. As the energy is low means wavelength will be high. That's why absorption occur at higher wavelength. Then it gives big bands in their absorption spectrum. Okay, N2 5-star transition gives big bands in their absorption spectrum. And then I will give you example for N2 5-star transition. Here, aldehydes and ketones, these are the example, well-known example for transition of N2 5-star. Okay, let's see, this is the aldehyde ketone function CO. Okay, then let's show H is also there. You can see here oxygen consists one pair of electrons. Here one pair, this is one pair. Total 2 pair of electrons are there. I told you that unsaturated molecules means constant oxygen, nitrogen, sulfur, or hydrogen. Here unsaturated, here double bond is there. So it is unsaturated and as well as consists atoms like oxygen. Okay, it consists lone pair of electrons and non-bonded electrons. Here in this transition, which electrons are undergoing transition? Non-bonded electrons. So these electrons you can see here. In this is lone pair of electron, non-bonded electron. These electrons are undergoing transition to 5-star. You can see this is shifted to here 5 1. Here we can observe overall it should be 4 electrons are there. Means 2 pairs are there. Here we can see 1 electron is shifted to this 5 1. Okay, means N electron shifted to 5 1, 5-star excited. Okay, N2 5-star that is. Okay, this transition is observed in acidic solution. We can observe in acidic solution how bands due to this transition disappear. In acidic solution, bands peaks due to this transition will disappear. And new bond is formed between acidic proton and lone pair of electron. New bond is formed. You can see here. This is the conjugate. This is the benzene which consists heteroatom nitrogen means this is building. Okay, you can see when it is present in acidic solution. Okay, you can see here peaks due to this lone pair of electrons will disappear. Means band. Okay, here bands due to this due to this trans disappear. You can see when it is present in acidic solution, new bond is formed between this lone pair of electrons and hydrogen. You can see here. Okay, you can observe same thing. Okay, new bond is formed between acidic proton and lone pair of electrons. You can compare. You can compare the heteroatom with this compound and without heteroatom. Okay, then you can observe the spectrum. You can know that. Then second type of transition is 5 to 5-star transition. 5 to 5-star. Okay, as you told. Okay, you can observe here 5 to 5-star. This molecule only consists 5 bonds only. Should not consist any lone pair of electrons. 5 electrons are undergoing transition. Okay, then it is occurring unsaturated centers. And molecules containing double bond, triple bonds, and also in aromatic compounds. 5 to 5-star transition occur in unsaturated means molecules must consist double bond or triple bond and also consist in aromatic because in the aromatic compounds double bonds or triple bonds are there. Then double bonds will be there. Then 5 to 5-star transition requires lowest energy as compared to remaining 2 N2 5-star transition and 5 to 5-star and N2 5-star transition and sigma to sigma star transition. Okay, then this transition gives BEK bonds. Here N2 5-star transition gives R bands. This gives bands due to this transition gives BEK. I can explain what is meant by BEK. Then examples which compounds will give 5 to 5-star transitions are ethylene, acetylene, and carbonyl, etc. These kind of compounds will give 5 to 5-star. You can see band and bands. I told you that BEK. B band means benzenite. B indicates benzenite. E indicates ethylenic. Okay, K nothing but conjugated system. You can see here B bands is appeared due to aromatic system. And aromatic nothing but benzenite and heteroaromatic. Heteroaromatic means aromatic will also consist heteroatom. Okay, then ethylenic. Okay, then K means conjugated system. Alternative carbon atoms having double bonds. And one example I given here how 5 to 5 star transition will occur. This is the ethylene example. This is C2H4. Here two bonds will be there. Here bonds appear, bonds formed due to transfer of electrons only. Here two bonds. Okay, this is one bond, this is one bond. Okay, two bonds are there. Here 5 electrons are moving transition. You can see here this is the pi electron. In this transition, these electrons are undergoing to here, excitation to excited. You can see these electrons are shifted to here. So this is 5 to 5 star transition. Next I will discuss about remaining N to sigma star and sigma to sigma star transition. Third kind of electron transition in UV visible spectroscopy is N to sigma star transition. Means here lone pair of electrons will undergo transition towards sigma star. Okay. Here this branch has a name suggests okay, the molecule is occurs in saturated compounds, means sigma bonded compounds. Saturated compounds containing heteroatoms like nitrogen, oxygen, sulfur and halogens. Okay, this type of transition occurs in saturated compounds containing heteroatoms. Okay, that you have to remember. Okay, here N to 5 star occurs unsaturated compounds containing heteroatoms. Why it is saturated means it is moving towards sigma star. That's why saturated compounds containing heteroatoms like nitrogen, oxygen, sulfur and halogens. Okay, this transition requires lowest energy as compared to the sigma to sigma star transition only. Means it requires highest energy as compared to above 2, means N to 5 star transition and as well as 5 to 5 star transition. Okay, and peaks due to this transition appear at 180 to 250 nanometer. It will appear at 180 to 250 nanometer in general. Okay, these peaks are appeared in lower absorption spectra. Transition due to N to sigma star appeared in lower absorption spectra, means here low wavelength. Okay, low wavelength, lower absorption spectra. Low wavelength means highest energy. Lower absorption spectra. Hence it is called as N spectrum. Hence it is called as N spectrum. Okay. Here examples of compounds which showing N to 5 star transition means methanol, ethanol, water, methyl chloride, etc. You can see here methanol is there. Here sigma bond is there and as well as oxygen, lone pair of electrons will be there. Here you can see ethanol is there. Here sigma bonds and lone pair of electrons will be there in the oxygen. And water, here oxygen will be there, lone pair of electrons. You can see this transition only occur in sigma bonds, the compound which consists sigma bonds and lone pair of electrons. Here this transition will not occur in the compound consists 5 bonds. That you keep in mind. Okay, for example, I give you an alkyl halide I have taken here. Okay, CH3Cl, you can say methyl halide. Here X is the halogen. Here it consists 3 lone pair of electrons, 1, 2, 3. Okay, when this transition occurring, you can see here this lone pair of undergoing transition. This is sigma bond, right? This electron is shifted to here. Lone pair of electrons, N electron, non-bond electron shifted to sigma star transition. This is sigma bond. You can see here this electron which is from here shifted to here. Okay, this reaction is representation N to 5 star transition. And last one is sigma to sigma star transition. Okay, it is given by all saturated compounds. All saturated compounds only. There is no double bond, there is no lone pair of electrons. Only it consists saturated bonds. It requires highest energy as compared to all. We have seen N to 5 star transition, 5 to 5 star and N to sigma star. Among those three, it requires very high energy. Very high energy means it requires a peak in the period higher wavelength. Okay, peaks due to this transition not occurring UV visible region. This is the transition not occurring UV visible region. Why? It requires UV because UV visible energy is not sufficient for excitation. UV visible energy, okay, it is not sufficient for excite the sigma electrons. Without excitation, we can't get a peak, we can't analyze. So here, but the peaks of 5 to 5 sigma to sigma star transition are appearing vacuum UV region, means less than 190 nanometer. Here 190 to 400 or 190 to 800 or 200 to 800, that is UV visible region. Less than 200, less than 190 nanometer, peaks will be appear sigma to sigma star, means it requires high energy. Here 200 to 800, that is high, okay, low energy. It requires low energy. So it requires high energy for absorption. Okay, for absorption, for excitation. Examples showing sigma to sigma star transitions are all saturated hydrocarbons like methane, ethane, propane, butane, etc. You can see this is the, for example, I consider ethane. Here one bond is there. We know that this is the bond. Okay, one bond will be there by 2 electrons. Okay, this is ethane, C2H6. Okay, here sigma electron. This is sigma electron, which is shifted to here, which is undergoing excitation after shifted to here. Okay, sigma to sigma star transition. So this is overall 4 types of transition occurring due visible spectroscopy. Then most important things are here. I discuss something. Okay, you can come here. And energy increasing order. We have seen 4 kinds of transition, right? Okay, the energy for energy required for transitions are first N to 5 star transition requires very low energy as compared to remaining. Then less than 5 to 5 star transition requires lowest energy remaining compared to these two. Then N to sigma star transition requires lowest energy as compared to sigma star. It requires highest energy, and N to 5 star requires lowest energy. Energy, this is the energy increasing order. This is important for G pattern hyper purpose also. Here N to 5 star transition less than 5 to 5 star transition less than N to sigma star transition less than sigma to sigma star transition. According if you talking about wavelength means here N to 5 star transition requires lowest energy means it will appear at higher wavelength. Okay, sigma to sigma star transition requires highest energy means appear at lower wavelength according to the wavelength. Okay, this is energy increasing order. This is important. And some more points. Polar solvents. Okay, polar solvent shifts N to 5 star and N to sigma star transition towards shorter wavelength. Okay, for suppose if any compound showing absorption at 250 nanometer means, if any compound showing absorption at 250 nanometer, for example, if we have any polar solvent, this absorption will be showing at 230 nanometer. 230 nanometer means here wavelength is decreasing towards shorter wavelength. That is the thing, shorter wavelength. That will be happen at N to 5 star and N to sigma star. If we have polar solvent to the 5 to 5 star transition compounds, okay, the transition occur in which compounds? Okay, in this 5 to 5 star transition towards longer wavelength. Okay, towards if we have this polar solvent will shift 5 to 5 star transition towards longer wavelength. Okay, important. Then hydrogen bonding shifts UV absorption towards shorter wavelength. Okay, if any compound, if you increase the hydrogen bonding means, okay, then UV absorption will be shifted to shorter wavelength. Okay, then carbonyl compound showing 2 kinds of transition. You need to remember carbonyl means, okay, CO like carbonyl compound showing 2 types of transition. What are those? N to 5 star transition, sigma to sigma star transition. Why CO carbonyl? Here oxygen heteroatoms will be there. Oxygen will be there. That consists lone pair of electrons. So that will be excited to the 5 star transition. Then here carbonyl compounds also having double bond. So 5 electrons are there. Those 5 electrons also will be excited towards 5 star. So N to 5 star and 5 to 5 star transition will be occurring carbonyl. But N to 5 star transition is low intense transition. Low intense peak will be observed. 5 to 5 star is high intense. Very important. These points are very important for G5 point of view. Thank you.